subscribe now and press the bell icon. Never miss an update.
Hi friends, myself Dr. Darshan Jani, and today we discuss about important topic of chemistry, that is organic reactions. So such topic is very important for MSc Sem I student, for interview point of view as well as university exam point of view. So it is very important. Also, don't miss to like and share the video. Subscribe the channel Chemistry Online by Dr. Darshan Jani and hit the bell icon to get regular notification for such important videos. Let me start today's important topic, that is organic reaction. So we will start with a very important reaction, that is NAF reaction. So first of all, we discuss which type of conversion is actually carried out in NAF reaction. So as we can see on the board that any nitroparaffins or nitro substituted derivative will be converted into aldehyde or ketone, or we can also say that into carbonyl compound. So this is the easiest way by which we can memorize any reaction as which type of basic conversion is carried out. So in NAF reaction, nitroparaffins or nitro derivatives will be converted into carbonyl compound, that is aldehyde or ketone. So how this conversion is carried out, let's see with the help of reaction. So as we can see on the board that nitro derivative such as nitrobutane, when you react it with sodium hydroxide, a strong base NaOH, right, then it will be converted into such type of intermediate compound, and then such intermediate is react with acid such as sulfuric acid H2SO4 to gives butanol, that is aldehyde derivative. So by this way such type of conversion is carried out. Now to see the detail of such conversion, right, to understand each and every step of NAF reaction, let me see about mechanism of NAF reaction, then how such conversion is carried out. So in mechanism, as we can see here that any nitro compound or nitroparaffins when react with strong base, as we all know friends that base will abstract proton, and here this alpha proton, that is carbon which is attached directly to the nitro group, is called alpha carbon, and the hydrogen attached to such carbon will becomes highly acidic. Why? As we have already learned in 11-12 science as well as in BSc, that inductive effect, right? Due to inductive effect, what will happen? This alpha hydrogen will becomes highly acidic in nature, that is easily removable or abstractable. So this base will abstract proton. As we can see by arrow that this bonding pair will be shifted between this carbon and nitrogen group atom, and this pi bonding electron will be shifted over oxygen and gives negative charge. So we will get such type of intermediate compound. Now when this intermediate is react with proton, so it will give such type of dihydroxy intermediate. Now in next step, what will carried out? Water molecule H2O will attack as a nucleophile. So as we can see here that in water molecule one of the hydrogen will lose, right? This bonding pair will be shifted over oxygen and lone pair of oxygen will attack over this carbon. So what will happen? This pi bonding electron will be shifted over nitrogen to satisfy the charge of nitrogen, and it may possible that this hydrogen may attach to nitrogen. So by this way, after this nucleophilic attack of water molecule, in next step what will happen, this lone pair of oxygen will shifted between this oxygen and carbon bond, and this bonding pair will lost by removal of this old group, right? So we will get such type of compound in which this remaining hydrogen will lose in form of H plus. This bonding pair will be shifted over oxygen to satisfy the charge of oxygen, and we will get our desired product, that is carbonyl, or here we can see that we will get ketone as a product. So by this way we can easily define each and every basic step for NAF reaction. As we have discussed in earlier video that any reaction is not completed without application part, right? So we will discuss here some important application of NAF reaction. As we can see here that in first application, when this diene 1,3-butadiene will react with such type of unsaturated nitro compound, so first of all it will undergo Diethylester reaction, then we will get such type of cyclic unsaturated nitro compound. When it react with titanium trichloride or in presence of catalyst such as TiCl3, titanium trichloride, it will give this nitro will be replaced by carbonyl, as we can see in product. And we all know very well that nitro will be converted into carbonyl with the help of NAF reaction. Then next application, as we can see here that in 1,2 position or in alpha position, when nitro and methyl group are there, when we react it first with LDA, that is lithium diisopropylamine, and next with molybdenum pentoxide in pyridine. So by these two reagent we will again convert this nitro group into carbonyl. So by this way we can easily convert any nitroparaffins, any nitro substituents into carbonyl compound, whether it is aldehyde or ketone, with the help of NAF reaction very easily. So friends, next important reaction for research point of view, right, is Wills-Mayer-Hack reaction. As it is known that any reaction which can synthesize an aldehyde, then it is very important for a research point of view. So our next reaction is used mainly in organic synthesis to synthesize an aldehyde, right? So our next reaction is Wills-Mayer-Hack reaction. So which type of conversion is actually carried out in this reaction? So any activated aromatic or heterocyclic compound when reacted with disubstituted formamide and phosphorus oxytrichloride, then it will give us aldehyde. Then this reaction or this conversion is mainly known as Wills-Mayer-Hack reaction. So how this reaction is carried out, let's see. So as we can see here that methyl ether of resorcinol when reacted with dimethyl formamide and phosphorus oxytrichloride in presence of certain amount of heat, it will give aldehydic product, or we can also say that it will give aldehyde as a product. And how this conversion is carried out can be easily explained with detailed mechanism of this reaction. So in mechanism of this reaction, when dimethyl formamide contain nitrogen heteroatom, and we all know that heteroatom having lone pair of electron. So this lone pair of electron is shifted between this nitrogen and carbon. So this pi bonding electron will be a takeover phosphorus of phosphorus oxytrichloride. So this pi bonding electron will be shifted over oxygen, and oxygen will get negative charge. and we will get such type of intermediate. Now in next step, what is carried out? This lone pair of oxygen is shifted between this phosphorus and oxygen. We will get here double bond, and this Cl will loss, so we will get here 2 Cl atom. Now in next step, this Cl may attack over this carbon. This bonding pair will be shifted between this phosphorus and oxygen, and again this pi bonding electron will be shifted over oxygen, and oxygen will get negative charge, and we will get this PoCl2O minus as a product or byproduct. So we will get here our first intermediate, that is denoted by 1 CH3 twice N plus and this CHCl. Now as we have discussed earlier that activated aromatic or heterocyclic compound, right? So this hydrogen will loss in form of H plus, this bonding pair will be shifted over this aryl group and it will attack over this carbon. So this pi bonding electron will be shifted over nitrogen, or we can also say that satisfy the charge of nitrogen, and we will get such type of intermediate. Now this lone pair of nitrogen again shifted between this carbon and nitrogen, and this Cl will loss in form of Cl minus, and we will get such type of intermediate product. Now hydrolysis of this compound will give us our desired product, that is aromatic aldehyde and such type of byproduct. So by this way we can easily define the mechanism for very important reaction, that is Wills-Mayer-Hack reaction. Now as we have already discussed that application part of any reaction, so here we are defining two important application for Wills-Mayer-Hack reaction. As we have discussed earlier that when any heterocyclic compound or activated aromatic compound reacted with DMF, that is dimethylformamide, and PoCl3, so it will give us aldehyde as a product, right? And the next one is anthracene. When you react it with same catalyst or reagent, that is DMF and PoCl3, and then after hydrolysis with sodium acetate in aqueous will give us aldehyde as a product. Also we know that in anthracene 9 and 10 position are highly activated, so we will get this aldehyde group at 9th position of anthracene. So by this way we can easily memorize important reaction for organic synthesis, that is Wills-Mayer-Hack reaction. So friends, third important reaction is Mitsunobu reaction. So which type of conversion is actually carried out in Mitsunobu reaction? So as we can see on the board that alcohol when react with triphenylphosphine, azodicarboxylate, diethyl azodicarboxylate, which is known as DEAD, and diisopropyl azodicarboxylate, which is known as DIAD. So this alcohol can be easily converted into ester, and this is the basic conversion of Mitsunobu reaction. So how this conversion is carried out can be defined with the help of detailed reaction and mechanism for this reaction. So it can be defined as when any alcohol react with acid in presence of pH3P, that is triphenylphosphine, and DEAD, that is diethyl azodicarboxylate. So this alcohol will be converted into ester. So how this conversion is carried out can be easily defined with the help of detailed mechanism of this reaction. So in mechanism, as we can see here, that when diethyl azodicarboxylate, why this molecule is known as diethyl azodicarboxylate? So here we can see that two ethyl groups are there, one azo group and 2 carboxylate ester. So this compound is known as diethyl azo dicarboxylate molecule. When this react with triphenyl phosphine, as we all know that phosphorus having lone pair of electron, so this phosphorus will attack over this nitrogen of azo group. This pi bonding electron will be shifted over nitrogen and nitrogen will get negative charge, as we can see here. Now when it react with acid, as we can see that, or we all know that acids are proton donor, right? So this hydrogen will lose in form of H plus, and we will get this bonding pair will be shifted over oxygen, and this hydrogen may attach over here to give this type of intermediate, and we will get finally the pair of ions. Now when this pair of ions react with alcohol, so what will happen? So this hydrogen may lose in form of H plus, this bonding pair will be shifted over oxygen, and alkoxy group, negatively charged alkoxy, may attack over this phosphorus. This bonding pair will be shifted over nitrogen and nitrogen will get negative charge. So this hydrogen may attach over this nitrogen to get such type of byproduct, and we will get this type of another pair of ions which get positively charged compound and negatively charged compound. Now after getting this another pair of ions, there are 3 possibilities for Mitsunobu reaction. All 3 possibilities are defined by 3 different colors. So we will go through all these 3 possibilities. First one is when this negatively charged oxygen may attack over this alcohol or hydrogen of alcohol molecule, so it may be liberated in form of acid as a byproduct, and we will get such type of compound as a product. So this is the first possibility of Mitsunobu reaction, or we can also say that this is the first way by these 2 ions are reacted with each other. Now in next way, what will happen? So this negatively charged oxygen may attach over this R dash group of positively charged ion. This bonding pair will be shifted between this phosphorus and oxygen, and we will get such type of ester and triphenyl phosphine oxide as a product. So this is the second possibility, and third one can be defined as this negatively charged oxygen may attach directly to positively charged phosphorus, and this alkoxy may remove, as we can see here. So it will give such type of intermediate, and which is rearranged to give such type of ionic pair as a product. So these are the 3 possibilities by which this Mitsunobu reaction is basically carried out. Now finally, the application part of this Mitsunobu reaction can be defined as, so it is mainly used to synthesize alkaloids, quinine, colchicine and morphine. Such type of compound can be easily synthesized with the help of Mitsunobu reaction. So friends, next important reaction is Michael addition. So it is a one kind of addition reaction in which alpha beta unsaturated carbonyl compound added to the active methylene group containing compounds such as malonic ester, acetoacetic ester, cyanoacetic ester. So such type of active methylene group containing compound added to the alpha beta unsaturated carbonyl compound in presence of base such as sodium ethoxide or any secondary amine such as piperidine, then such addition reaction is known as Michael addition. So how this reaction is carried out, let's see with the help of reaction and mechanism. So as we can see here in reaction that any alpha beta unsaturated carbonyl compound, when it react with active methylene group compound in presence of sodium ethoxide, it will gives us such type of desired product, right? So in mechanism of this Michael addition, as we can see that first of all what will happen, this base is react with active methylene compound and it will give an anion or generate an anion, as we can see here. Now this anion will or negatively charged carbon will attack over this carbon in alpha beta unsaturated carbonyl compound. So what will happen, this pi bonding electron will be shifted between these two carbon. This pi bonding electron will be shifted over oxygen to get negative charge on oxygen, right? So we will get such type of compound. Then it react with alcohol, which is also known as proton donor, right? So it will abstract proton from this alcohol and we will get such type of intermediate compound. Now in next step what will happen, this hydrogen will lose, this pi bonding bonding electron will be shifted between this oxygen and carbon, and this pi bonding electron will be shifted over carbon and this carbon will get negative charge, and this hydrogen may attach here to give such type of our desired product. So this particular reaction is known as, or this particular addition is known as Michael addition. Now if this Michael addition followed by internal Claisen condensation, then what will be the product? So it can be defined as this product of Michael addition when react with one more alkoxy group, right? So as we all know that this alkoxy will abstract proton from this particular carbon which is adjacent to carbonyl. So we will get here negatively charged CH2 group, and we can define this remaining compound in cyclic form as we can see here. Now what will happen, this negatively charged carbon will attack over carbonyl carbon of ester, right? So this alkoxy will remove and in form of OC2H5 minus, that is ethoxy, and we will get such type of cyclic compound which will further react with as we can see here potassium hydroxide and H plus, that is acidic hydrolysis, we will get diamidone as a product. So by this way we can easily memorize one of the important reaction from a university exam point of view, that is Michael addition. Again remember that addition between alpha beta unsaturated carbonyl compound and compound which contains active methylene group, then this addition reaction is known as Michael addition. Now when we discuss about application of this Michael addition, so as we can see here that any active methylene compound when react with any alpha beta unsaturated compound in presence of base such as sodium ethoxide, we will get such type of desired product. So by this way we can easily memorize important addition reaction, that is Michael addition. So friends, next and last important reaction for this video is Dickmann condensation. So it is nothing but inter or intramolecular Claisen condensation to give cyclic ketone as a product. So how this conversion is carried out, let's see with the help of reaction and mechanism. So as we can see here that diethylester of adipic acid and diethylester of pimelic acid when react in presence of base, it will give 2-carboethoxy cyclopentanone and 2-carboethoxy cyclohexanone as a product respectively. So it is nothing but intramolecular Claisen condensation for the preparation of cyclic ketones. So there is one more case by which we can define the same Dickmann condensation as short chain ester of dibasic acid. When we take ethyl ester of succinic acid, or we can also say that ethyl succinate, right? When we react with the same reaction, we will get cyclohexanedione as a product, right? So for the detailed study of same reaction, that is Dickmann condensation, we will go through the mechanism of this reaction. So as we can see here, that diethyl ester of adipic acid, when react with base, what will happen? It will abstract, as we all know that base will abstract proton from any of this CH2 group. So there is formation of negative charge here. Now this negatively charged carbon will attack over this carbonyl carbon as it get partially positive charge. So what will happen? This pi bonding electron will be shifted over oxygen. So this oxygen will get negative charge and we will get cyclic product like this. Now in next step, what will happen? This pi bonding electron will be shifted between this carbon and oxygen, and this ethoxy group will loss as a byproduct. And in next step, after formation of this carboxyl or a ketone group, right, what will happen in next step? This hydrogen will loss in form of H plus. This bonding pair will be shifted between this carbon, and this pi bonding electron will be shifted over oxygen. So we will get unsaturation between these two carbon, and oxygen will get negative charge. Now the next step, that is hydrolysis of this intermediate, will gives us this ester will be converted into acid, and this ethyl substituent will remove or loss in form of ethanol with this hydrolysis. And final step, that is decarboxylation of this compound, will gives us our desired product, that is cyclopentanone. So by this way we can easily define inter or intramolecular Claisen condensation to gives cyclic ketone, that is Dickmann condensation. Again, the application part of this reaction can be defined as any dialkyl ester or any ester of dibasic acid, as we have taken here two examples, when it react with sodium hydride or potassium salt of N-butanol, that is N-butoxide, right, and followed by hydrolysis in both the step will gives us cyclic ketone as a product. So by this way we can easily define important reaction, that is Dickmann condensation. Also the remaining reaction of this chapter we will discuss in our next video. Don't miss to like and share the video. Subscribe the channel Chemistry Online by Dr. Darshan Jani, and hit the bell icon to get regular notification for such important videos. Thank you very much.